Hello and welcome to the debate. Today's debate is on appropriate construction materials. The two materials up for debate are concrete and timber. Mr. Crete will be debating on the side of concrete, while Mr. Burr will be on the side of the only appropriate alternative, timber. We want you within the classroom to participate by answering any questions. You can do this in groups if you like. Also, watch out for any key points that pop up on the screen and the newsfeed, as these are very important. Shall we begin? First question, Mr. Crete and Mr. Burr. Can you tell me a little about your material? But first, can you in the classroom tell me?
Thank you, class. Concrete is a construction material composed of cement and aggregate. Aggregate is generally made up of gravel or crushed rock, such as limestone and granite. It is also added with fine aggregates, such as sand. This is added with water and chemical admixture. Concrete solidifies and hardens after mixing with water and placement due to a chemical process known as hydration. The water reacts with the cement, which bonds with the other components together, eventually creating a robust stone-like material. Concrete is used to make pavements, architectural structures, foundations, motorways, bridges, parking structures, blockwork, and also Ardnacrusha, the largest hydroelectric power station in the world when it was first constructed.
Mr. Burr, tell me a little about your material.
Thank you. Timber is one of man's oldest building materials. It is a renewable, naturally sourced, organic material in a world full of synthetic and composite building materials. Today, timber is derived from sustainably managed forests in most parts of the world as well as Ireland, and is one of our most environmentally friendly building materials. The wide distribution of timber, its ready availability, variety of uses and relative ease of handling and conversion have all contributed to its wide acceptance in the building industry.
Mr. Crete, why should we use your material in construction?
What about the class? Let's give them a go first.
Very well. Class, I pose a question to you. Why should we use concrete in construction? Thank you, class. Mr. Crete.
Concrete is one of the most durable building materials. It has far superior fire resistance than any wooden construction. As well as that, it gains strength over time. Concrete is also the most widely used construction material in the world, with annual consumption between 20 and 30 billion tonnes. Also, concrete production is Irish-based, securing Irish jobs with all the materials sourced in Ireland. Concrete has a very low coefficient of thermal expansion, and as it matures, concrete shrinks. All concrete structures will crack to some extent due to shrinkage and tension. Concrete that is subjected to long duration forces is prone to creep, but there are ways to solving this by means of pre-stressing concrete.
Mr. Burr, over to you. Why should we use your material in construction?
There is a large localised timber industry in Ireland, reducing transport costs and cutting fossil fuel emissions. This enables for economic, fast construction of dwellings, where there is no need to wait for the material to cure over time, unlike concrete, where there is a 28-day waiting period before heavy construction. Construction with timber isn't dependent on ideal weather conditions, while concrete cannot be poured while there is freezing weather because it will not hydrate properly. There are specific regulations governing the use of structural timber in the construction of houses in Ireland. These regulations provide guidance on the species, strengths, sizes and marketing of timbers for various applications once the strength of the timber is known. A number of mechanical tests are carried out in timber: bending strength, tension, compression and the shear test. When these tests are finished, a visual inspection is carried out in this called grading. Timber is an environmentally friendly material. When harvested from sustainable forests, it is a renewable carbon neutral material, making it one of the most environmentally friendly materials for construction.
Mr. Crete, what do you say to people that claim that your material is not sustainable in today's society?
Thank you. Let me highlight some of the key information. Yes, concrete is one of the primary producers of CO2, and 5% of the world's man-made emissions is from concrete. 50% of that is from the chemical process, and 40% from the burning of fuels to create concrete. The CO2 emissions from the concrete production is directly proportional to the cement content used in concrete mix. Indeed, 900 kg of CO2 are emitted for the fabrication of every tonne of cement. Cement manufacture contributes greenhouse gases both directly through the production of carbon dioxide when calcium carbonate is thermally decomposed, producing lime and carbon dioxide, and also through the use of energy, particularly from the combustion of fossil fuels. However, some companies have recognised the problem and are envisaging solutions to counter their CO2 emissions. The principle of carbon capture and storage consists directly of capturing the CO2 at the outlet of the cement kiln in order to transport it and to store the captured CO2 in an adequate and deep geological formation. With its 100-year life cycle, concrete conserves resources by reducing the need for reconstruction, unlike tin decay if not treated. Buildings constructed of concrete have a unique energy-saving advantage because of their inherent thermal mass. Thermal mass is a property that enables building materials to absorb, store, and later release significant amount of heat. These materials absorb energy slowly and hold it for much longer periods of time than do less massive materials. This decay and reduces heat transfer through a thermal mass building component, leading to three important results. First, there are fewer spikes in the heating and cooling requirement, since mass slows the response time and moderates indoor temperature fluctuations. Second, a massive building uses less energy than a similar low-mass building due to reduced heat transfer through the massive elements. Thermal mass can shift energy demanded to off-peak times periods when utility rates are lower. Since power plants are designed to provide power at peak loads, shifting the peak load can reduce the number of power plants required.
Mr. Burr, is there not numerous problems with using timber in construction?
No, there are points of care, not problems. One such point is fungi caused rot. The two main types of fungi caused rot are dry rot and white rot. However, rot can and should be prevented by ensuring that untreated timber is well ventilated and by correct use of DPC in such places as suspended timber floors. Rot is caused by dampness. By removing the source of dampness and by providing adequate ventilation, rot is not a concern.
Mr. Crete, how does your material contribute to our society?
Concrete has helped create what previous generations thought was impossible. Through concrete, we've been able to harness rivers to produce electricity. Concrete has built the modern world. Look around you. I'm sure that the room you're sitting in is made of concrete.
Mr. Burr, how does your material contribute to our society?
Timber is a natural material, having existed for millions of years. Trees are the lungs of our planet. As we use timber within construction, we are at one with nature, using a material that man has used for thousands of years. Its use promotes a sustainable society, a society that leaves the environment to our descendants as they would want it. It is a renewable energy source when harvested from maintained forests and is thus carbon neutral.
This question is for the class. What are the future prospects of your material? And with that, thank you very much for being part of our debate today. Goodbye.